Hello everyone. So, in our last lecture video, we introduced the idea of logarithms, a new type of operation we're going to be using in this class. And during that, I gave a list of some very minor properties of logs. So today, all we're going to be doing is adding on to that list and giving some more useful properties of logarithms that we're going to be using from now on. So let's go ahead and get right on into that. Okay, so in our last lecture video, we talked about how we could solve logarithms by hand, right? We talked about how it's just a game. All logarithms can be converted into an exponential, and then you solve the exponential to solve the logarithm by hand. However, there were some problems with that, right? If we ever got logs with fractions or decimals, those are kind of hard to solve by hand. We don't really have the ability to do those by hand, just because their answers are irrational numbers and they're just going on forever. So, because of that, we talked about then how sometimes we have to use a calculator to solve logarithms. But we're very limited in that regard for this class because we're only allowed scientific calculators. So in regards to scientific calculators, they only have the ability to use log, which is log base 10, and ln, which is log base e. Any other log base, the scientific calculator can't do. So that's why I want to start today's lecture by asking this question. How then would we calculate something like log base 4 of 3, right? Well, just to run through what we've talked about, like if we tried to do the, this equals some unknown value. So if we tried to do the exponential form, this is saying what power of 4 makes it equal to 3. And that's not something we're going to be able to do by hand, right? That's 3 is not a power of 4. There's not much we can think of. We already know this is going to be some form of a decimal answer. So the next thing is, let's use our calculator. But again, as we just talked about, this is log base 4. This is not base 10 or base e. Our scientific calculator won't let us solve for this. So the question then stands, are we just out of luck for problems like this? For any logarithms that aren't base 10 or base e, can we just not solve them for this class? Well, of course not. No. And the answer to how we're going to solve this is going to be our first property of logarithms we're going to talk about today. It's going to be this idea of change of base. So, can solve this by using the change of base property. Okay, and kind of as the name implies, change of base, we are going to change the base of our logarithm. Remember, base is the subscript number. What are we going to change it to? Well, if we think back to our tools, we have our calculator that uses base 10 and base e. So this change of base formula is going to be a property we can use that changes the base of any logarithm to base 10 or e, and actually, as we'll see, you can just change it to whatever base you want. And it's a very useful property for us because then it lets us solve problems like this. So let's go ahead and get into our discussion of what exactly is the change of base formula. Okay, so I thought it'd be interesting to go ahead and let's just derive this change of base formula, because we actually have all the tools, well, most of the tools currently, in order to understand the derivation of how this formula actually comes about. So it goes like this. If we start with any old logarithmic expression, y equals log base a of x, okay? And the goal of this derivation is going to make log base a and change that to a log base b, or b just some other base. So how the derivation goes is like this. First, we want to rewrite as an exponential. Okay, so we end up getting a to the power y equals x. Okay? Then the next step in the derivation is you want to take on both sides, you want to take log of your new base. So we're going to take log base b. So I guess this is 1, 2, we're going to take log base b on both sides. So we get log b of a to the y equals log base b of x. Alright. Now, the next step is the one step that we actually don't have the tool for yet, so you're going to have to take my word on it. We will discuss this step later in today's video, but for now we haven't gotten to it yet. And the third step is, and we'll actually come to know this as the power property. But for now, what the third step is that this power of y on a can be brought to the front of the logarithm. So we get y log base a, oh my bad, y times log base b of a equals log base b of x. Okay? Then we're going to go ahead and divide that over. I guess, let me write that down. Divide by log base b of a. So when we divide by log base b of a, lo and behold, what can we notice? Well, I now have a new expression of y. It is only using log base b on that side, in contrast to our original expression of y, which used log base a. So we have successfully changed that y equals a log base a value into that y equals a log base b value. Granted, there is a division of logarithms here. That's no big deal. We have still accomplished the main goal in that y now equals a logarithm value that uses an entirely different base. There is no log base a here. That's the point. No log base a. That's the big idea. We don't really care about the fact that we have two logarithms. That's not a big deal. The big deal is that we have removed that original base and we are now using an entirely new base. So this is the derivation. It's pretty short, and I thought it'd be just cool to derive it. Like I said, the one thing we can't really understand yet is this third step. It's just applying a property we haven't talked about yet, but we will talk about it later in the video. So this is the derivation for the formula. Now let's just go ahead and write it down formally, and let's do a quick example using it as well. Okay, so just to write a bit more formally, here it is, the change of base formula. It goes like this. Log base a of x equals log base b of x divided by log base b of a. Alright, here it is, pretty straightforward formula, very useful formula. To go ahead and describe it or talk about what's going on here, I guess more in words, all it's simply saying is if you want to change the base of your logarithm, you can do so by taking the log of your new base of x, dividing that by the log of the new base, and then evaluating that logarithm with the old base. Okay? So this is kind of the key step right here, is you do log new base of the old base. Okay? And using this, you can successfully change any base logarithm into whatever base you want. There is no restrictions. There is no restrictions on the base you can change into, granted that you're changing into a valid base. So, yeah, that's how that works. So for us, again, why is this so important? Using this formula, we can take any log base, change into a log base 10, change into a log base e, and then from there, we can then calculate any logarithm by hand. So why we care so much about this is we can use this to calculate any log with a scientific calculator. Alright, any log now we can solve using a scientific calculator since we have access to this change of base formula. So, my voice is cracked. So, to go ahead and do an example, going back to that original question we asked, what is log base 4 of 3? Well, let's go ahead and just change the base. We can change this into base 10, base e, doesn't matter as long as we change it into one of them. So if we change it into base e, we're going to get ln of 3, right? Our a in this example is 4, so our a is 4. Our x is 3, so I want to do log of my new base, which I'm going to do ln of our x, so of 3, divided by ln of 4. And this is going to be approximately This is approximately 0.7925, let's call it. And there you go. This problem that we no longer could solve can be easily solved now just using this formula. Alright? I guess it's worth showing that if I had done log, right, because we had two options we could have changed to. So I could have changed this to log base 4, or log base 3 over log base 4. Right? And we should expect that this value gets the same result. Why is that? Well, these are both supposed to equal log base 4 of 3. So if they both equal the same value, they should be outputting the same number, right? And so we just test that in our calculator real quick. 3 divided by log base 4. Yep. Without any surprises, we can see that it does equal the same exact value. Again, because they are both equal to that original log base 4 of 3. So just wanted to point that out. It does not matter which base you change into when solving with your calculator. They should equal the same number regardless of what base you change into. So there's change of base. So actually, let's have you guys do a quick example. Why not? I'm going to go ahead and erase from here down. So if I've done so already, go and pause the video at this point to get any of this copied down. Okay, so let's have you guys try using this real quick on your calculator. Go ahead and find for me what log base 7 of 5 is. And I encourage you, try with ln and log and see for yourself that these actually, when you change into either of these bases, you still get the same answer. That's a very important observation I would like all to do on your own and just see that it is true. But regardless, go ahead and pause the video now, take a couple seconds, calculate this log. I'll write down what the approximation I get is, and we can check just to make sure you're inputting correctly into your calculator. So go ahead and pause the video now. Okay, so hopefully you gave it a shot, and hopefully you tried both bases just so you can see that they equal the same thing. And what I got off my calculator was 0.82709. Let's round up to there. Okay, so hopefully you got something similar. I guess I should say I did round right there, so if you kept on going, that's fine. Just make sure that up until the, what is that, 5th decimal place, if you round, you get the same value as me. If not, double check how you're inputting the function into your calculator. You should be doing something like ln, if you used ln, you should do ln 5, n parentheses, divided by ln 7, n parentheses. That's how it should look like when you're inputting into your calculator. Alright then, so this is our first new property of logs for today. Let's go ahead and make up some new, let's go ahead and talk about some new other ones as well. Alright? Okay, so before we get into our next set of properties for logs, I actually want to go back and I want to recall something. I want to recall the following properties of exponents. That being the product, quotient, and power property of exponents. So we've talked about these before in the class, so hopefully this should all be review. And just to make sure we get some review, I want everyone to go ahead and pause the video, take a couple seconds, fill out these three equalities. What does ax times ay equal? What is ax divided by ay equal? And what is ax to the power of y equal? Okay? So go ahead and take a couple seconds to fill this chart out. Alright, hopefully you filled it out, and hopefully it wasn't much, you could do it without much difficulty. If you had some problems filling it out, no problem. We'll discuss it right now. Alright, so let's remember, if you are multiplying two values together that are the same and they have exponents, that means you get to add the exponents. Alright? Very similarly, if I'm dividing by a value in which the value is the same and they have powers, then I get to subtract the exponents, right? And lastly, if I have a value with a power and I take it to another power, you get to multiply the exponents. So ax times y, right? Here are three basic properties of exponents we have probably been using religiously throughout this class. So, why do I bring this up, right? We're talking about logs today. Why do I even bother bringing up these exponent properties? Well, the reason why, and hopefully you guys all remember from our last lecture video, what was the big idea I talked about for logarithms? Why do we even bother mentioning them? Because they are the inverses to exponentials, right? That was the core idea. Exponentials and logarithms are connected by the fact that they are inverses of each other. So, why do I bother writing down these properties of exponents? Well, that's because, and hopefully it isn't too much of a jump in logic for you to understand this, is that if these are properties of exponents, and exponents are and logs are connected by the fact they're inverses, all three of these properties can be directly translated in some manner into properties of logarithms, right? So, just to kind of tie things all together, the next set of logarithm properties we're about to discuss all come from these three exponent properties. Again, the connection of them being inverses. These three exponential properties can be directly translated into our following new three logarithmic properties. So let's go ahead and write down those log properties. And as we're writing them, keep in mind that, again, I guess I should say, I will label the next three log properties as product, quotient, and power. Keep in mind how the product property of logarithms is coming from this product property of exponents. The quotient property of logarithms is coming from this quotient property of exponents. And the power, just like that. Alright, so with that out of the way, let's go ahead and actually write down these next three properties of logs. Okay, so here they are. Here are the next, our next three properties of logs. We have the product property of logs, and it goes like this. Log base a of x times y, so log of a product inside the logarithm, this will equal log base a of x plus log base a of y. Alright, so if I have a log and inside that log is a multiplication, I can split that into adding two separate logs with the same base. Okay? Very similar to that is the quotient property, and the quotient property goes like this. Log base a of x divided by y equals log base a of x minus log base a of y. Again, if I have a logarithm, inside that logarithm is a division. I can then split that into two separate logs with the same base and have a subtraction between those logarithms. That's all the quotient property says. Lastly, we have the power property of logs, and this says the following. Log base a of x to the power of n equals n times log base a of x. So to put this in words, log of a value with an exponent will equal the exponent times log of that value. So you can bring the exponent out into the front. That's what the power property is saying. Okay? And actually, to reference back to our derivation of the change of base formula, that missing step, that step 3 I talked about, was an application of our power property. So this was that missing step in the derivation. Of change of base. Okay, so here they are. Here are three new properties of logarithms. These are extremely helpful properties of logs when you're doing any problem that ever exists that involves logarithms. Like, there's a solid 80% chance you're going to end up using one of these three properties in some manner. They just happen all the time. Logs get super messy. They can be super ugly to work with in their raw form, so a lot of the times it's just a matter of using these three properties or that change of base or even the ones we discussed last time just to make them simpler to look at and easier to work with. Okay? So take a moment, definitely get this all copied down, these three properties, and actually after that we'll go ahead and move on into doing some examples, several examples that use these properties. So go ahead and pause. Alright, let's get right on into that. Okay, so let's go ahead and consider the following example. Show that minus ln of 2 divided by e equals 1 minus ln of 2. Okay? So, we actually haven't done a problem like this before too much in this class, in that this is a proof problem. Right? We are going to prove that this equality is true, that this side actually equals the other side. Now, since this is a proof problem, we have to be a bit careful in how we solve this problem, in that when you are proving equality, you cannot work with both sides of the equal sign. You can only work with one, right? In other words, what I'm trying to say is we cannot manipulate this expression and we cannot manipulate this expression at the same time. In other words, we can't change both sides of the equal sign and have them match up somewhere in the middle. No, that's not allowed. In order to successfully solve this problem, you have to choose one side of your equal sign or one side of your equality and only work with that one side. Right? So like what I'm going to do for this example is I'm going to take this side of the equality. I'm only going to work with this side of the equality and I'm going to show that it equals this expression. So notes can only work with one side of the equality. Okay, so just a quick thing to note when you're doing like these proof equality type problems is you can only work with one side. Show that one side can be transformed into the other side. And also I just want to take a quick moment to talk about why this is going to be a very nice example for us. And the reason why is because a lot of the problems we can do in this class can seem like there's only one way to solve it, and that it's a very and it just kind of gives the impression that when doing math problems are very linear, they're very straightforward. There's like only one approach you can take. And that's very disinformative of just math in general and solving math problems, because it's usually not the case. That's usually not how it goes. A lot of times when you're tackling a math problem, it actually is very open-ended. It's kind of up to you to how you want to tackle it. Granted, of course, that you have the background in order to take all these different options. So for us, we're still kind of building up our backgrounds. That's why a lot of the problems when we're solving them seem like there's only one path to do it, just because we haven't built that repertoire of tools and techniques for us to use to allow us to tackle problems in several different ways. However, for this problem, it's actually going to let us glimpse into that, in that we're going to be using our logarithm properties to solve this. But since we're going to have several properties for us to use, there's actually several different ways you can tackle this problem and get to the end result. So I'll go ahead and do this problem, but just because I do it that one way and how I present and how I use the properties in certain orders is not indicative at all of how you have to solve the problem. You could solve it the same exact way as me, but there's actually different manners in which you could solve this problem. So that was actually one of the big reasons why I want to do this example, was just to help enforce that idea that and try to break away from the mold that math is super linear and you have to be doing problems in certain ways. That's not the case at all. If you understand the topic enough, if you understand the material, you can actually explore or solve a problem in whatever way you want. So, with that whole nice little speech out of the way, let's go ahead and actually try solving this example. So in order to do that, I'm going to go and erase this part in red. So I haven't copied this down. Go ahead and copy it down. Okay, so right, so as I said, I'm going to take this side of the equality. So if I start with minus ln of 2 divided by e, I want to convert this into 1 minus ln of 2. Alright? So now it's kind of open-ended. Yet again, the ball's in our court. How do we start this off? So when I want to start this problem, what I think to do first is I notice something. I say, well, here I have 1 ln, and here, or actually, in other words, here I only have one value, this single ln. But over here, what I want to get to, right, so this is my goal. My goal has two values. It has a 1 and an ln. So in other words, I have one expression here, and I'm going to want at the end two expressions. So how could I split this single expression into two expressions? Just so I have two things to work with, because that's what I want to get to, is two different values. So when I'm thinking along those lines, I'm saying, well, I have a logarithm, and inside that logarithm is a division. So going back to that list of properties we just wrote, quotient property lets me take a single log and split it into two separate logs. I have a single value, I split into two values. That's kind of moving towards the goal we want, all right? So let's go and do that. So my first step is going to be apply quotient rule, or quotient property. That's going to be my step number 1. And so doing that, I'm going to get minus ln of 2 minus ln of e. All right. Now, we need to take special note of something in my step right here. And what we have to take note of are these brackets. It's very important that I wrote these brackets. Why is that? Because right here, out in front, I was negating the entire ln value, right? So this ln will equal this difference of ln's. So if I was negating this ln right here, I need to negate this entire difference. That is why I put brackets here. Or, if you prefer, you can write parentheses as well. Doesn't matter. I just wrote brackets because I don't really like mixing parenthesis and parenthesis, but that's regardless of the matter. What's important is that I was negating this ln equals these difference of ln's, so I need to negate the entire difference. All right? So then, from there, well, let's go ahead and just get rid of these outer parentheses. Let's distribute that negative value. So if I distribute the negative, let me go ahead and box away that. So if I distribute the negative, I distribute the minus, I'm going to get ln of e minus ln of 2. Alright, and so from here, we kind of should just take a step back. We've done 2 steps. Let's kind of reorganize ourselves, reaffirm what our goal is, and see how we're doing, right? So my goal is 1 minus ln of 2. I now currently have ln of e minus ln of 2. So we're pretty happy at this point. And why is that? Well, I have that minus ln 2. Alright, I have a majority of what I'm looking for that goal solution. The only thing is I'm missing 1. I need to somehow get a 1 into this expression I currently have. And so that's where we just kind of sit back and think for a minute and we go, oh, would you look at that? Would you look at that? I have an ln of e. Alright? What is ln? ln is log base e. So I'm doing log base e of e. Going back to yesterday's video, that is a property of logarithms. Log of base a of a, or for us, log base e of e, must equal 1. Aha. So use... So we're using that log base a of a equals 1. And so this tells us that we now have 1 minus ln of 2. And just like that, what do you know? We now have shown that the equality is indeed true. All right. I guess I should emphasize that every step along the way, we have done just equalities. It is true that this ln equals the difference of ln's. It is true that this expression, when distributing the negative, equals this expression. It is true that ln e equals 1. Everything we've done has been using only true equal statements. All right. So we have successfully shown or proved this equality. Now what I encourage you to do is to go ahead and try tackling this problem again, but do some different steps for me, right? So like here I use quotient property first. Try not using quotient property first. Try doing a different step. Or start from here and work the other way. So start with this expression and show it equals this expression. Like I said, several different ways we can tackle this problem. Much more interesting example. But here's that. just to give us an introduction of how we can use these properties of logs, right? Here's one of the ones we talked about today. Here's one of the ones we talked about last video. So with that out of the way, go and pause the video at this point. Get all this copied down. Alright, so now let's go ahead and just try doing more examples, again using these properties we've introduced today. Okay, so for our next example, let's go ahead and consider the following problem. Let us condense the expression into a single log expression. In other words, let's take this big old thing we've written down, that being 5 times log of x minus 1/2 times the quantity log of y plus 4 times log of z to the 7/2 power. Let's take this whole big thing and let's shrink it down. Let's use those property of logs and let's rewrite this as a single log value. Alright? So, as I kind of just mentioned, the whole idea behind this problem, the whole process of solving this problem is just repeated applications of those logarithmic properties we listed previously in the video. So, let's go ahead and tackle the problem. Alright, well then, before I even consider the logs, before I even consider doing anything with logs, there's a simple distribution I can do, right? Don't have to bother with the logs yet. Let's go ahead and just distribute that minus 1/2. Let's make sure everything's been distributed and we have the things we need to work with. So distributing that minus 1/2, I'm going to end up with 5 log of x minus 1/2 log of y minus 2 times log of 7 or z to the 7/2 power. Alright, so now I only have the log values. So let's start working with these. Going to need to start applying those log properties. So I want to convert this into a single log expression. So with those properties we have, right, I could notice that right here I have a difference of logs. And so quotient property tells me that the difference of logs can be written as a division inside a single log. Now however, we have to be careful, because we cannot use the quotient property here yet. This is a very important note. We cannot use quotient property yet. I've forgotten how to spell quotients. Yes, quotient property. Alright, very important note is with these two logs, we still cannot use quotient property, right? Why? Why can we not use quotient property? It is because of the coefficients. Alright? So, you cannot use quotient property if you have coefficients in front of your logarithms. You can't use quotient or product property, I should mention. Can't use quotient or product property with if coefficients are in front. Alright, so those coefficients, the 5 and the 1/2, are currently in the way of us using our quotient property, of us combining these two logarithms into a single log value. Alright, so the question then needs to become, well, how do I handle these coefficients? Alright, and that's not a big issue for us, because we simply go back to that list, and right below quotient and product property was that nice power property. Alright, so power property told us that if I have an exponent inside my logarithm, that exponent can be brought out to the front and multiplied. You can just do the exact opposite. If I have a number multiplied in front of the logarithm, you can bring it inside and make it an exponent. So, wrap things all together. We will want to be using quotient property because of that subtraction, right? So that subtraction does tell us you will use quotient property. But before we can use quotient property, we need to use power property. So let's go ahead and do that. Alright, in order to do that, I'm going to need to erase this part in red. Please make sure you get these notes written down. These are actually important notes. So I'll go and give you a second to pause and copy these down. Okay, so let's go ahead and do power property first. Alright, and let's note that we have 3 places we can use power property. We have it with the 5, with the 1/2, and with the 2. So let's use power property. Okay, in using power property, we end up getting log times x to the minus 5. Oh, my bad. I don't know why I said minus. Log times x to the 5th power minus log times square root of y, and then plus log of z to the minus 7. All right? So here's what happens after we use the log property. Now I want to go ahead and point something out. Okay? I'm going to go ahead and erase these blue boxes. Now the part I want to point out is our steps between these two values. Okay? So when I was using the power property from here to here, or from here to here, I took the 1/2 and I brought it inside. So I have minus log of root y. Now over here, I took the minus 2, so I have minus log of z to the 7/2. Now from this step to this step, I took the minus 2 and I brought it inside. That's why I now have log of minus 7 over, my bad, I now have log of z to the minus 7th power, and I have a plus right here, all right? So here I left the minus outside, and over here I brought the minus inside. Does not matter which path you take. Both are totally valid. I just wanted to show you guys that you could do it either way. So I could have easily just left the minus out right here, and I could have easily brought the minus in right here. I just wanted to show you both ways. Doesn't matter which way you do. They're both totally valid. So I just wanted to point that out in case there's any confusion. Again, here I left the minus inside when I used power property. Here I brought the minus inside when I used power property. Doesn't matter which way you do it. So we get to here, and now we have power property. So now all the coefficients have been taken care of, right? All the coefficients have been brought inside. Now I solely just have a bunch of logs being added and subtracted together. It is from here that I can use those power and quotient properties, okay? So let's go ahead and do just that. Though I am going to need the board space. Oh, see, I've forgotten R. I'm going to need the board space. So you haven't done so already, pause the video, get this work from here to here copied down. Then I'm going to go and erase the board and continue from this step here. So go ahead and pause now. Okay, so we are currently looking at log of x to the 5th minus log of square root of y plus log of z to the minus 7th power. Okay? Let me go ahead and cut away those directions. Alright, so we're here. Now it's just us using those quotient power properties, right? So right here, I have a difference of logarithms. A difference of logarithms means we can use quotient property. So here's quotient. So using that quotient property, I'm now going to get, right? So log of A minus log of B equals log of A divided by B. So I now have log of x to the 5th divided by square root of y. Alright, and I'm still adding that last logarithm plus log of z to the minus 7. Okay? Alright, so from here, let's go ahead and see that we now are adding two logarithms. So this is a product property application. We can use the product property, log of A plus log of B equals log of A times B. Alright? Now before we get into that, I do want to note that's z to the minus 7 power equals 1 over z to the 7th power. So remember, all negative exponents can be written as fractions. So then I'm going to simply rewrite this as a fraction. We get 1 over z times 7, or z to the 7th power. Using that product property of logs, we then get that we have log of x to the 5th divided by square root of y times z to the 7th power. And there you go. We have successfully taken that one big expression we had and we've condensed it down into a single logarithmic expression through using our, using our properties of logarithms that we've discussed. Again, just like that proving example, several paths you can take to solve this problem, several different ways, orders in which we can apply the properties. Doesn't matter how you do it, as long as you're doing it correctly, you should get the end results. That being this expression. So yeah, that's that. I find these problems enjoyable, kind of like puzzles. Here you have all the pieces spread out. We're just combining them all together. So let's actually, on that note, have you guys go ahead and try working on one yourself. So will you do the same directions, condense the expression into a single log expression, but we'll use a new function or a new expression. So I'm going to need to erase the board. So if you haven't done so already, go and pause the video now to get all of this copied down. Alright, so now for the chance for you guys to get your hands dirty, let's go ahead and have you guys do the following expression. Condense for me 6 times ln of x minus 1 plus 1/3 times ln of z minus 2 ln of square root of y. Okay, so here's your expression. Go and take a moment now, pause the video, condense this expression into a single logarithmic expression using those properties of logs we now have under our tool belts. So go ahead and give this problem a shot. Okay, so hopefully you gave the problem a try, and I'll go ahead and give my answer that I got now. We can go and compare. So the answer I got was ln of x minus 1 to the 6th power times cubed root of z all divided by y. This was the answer I got. All right. I guess I should have probably noted at the before I sent you guys to work on it, is that here we're using ln. In our previous example, we used log, right? Doesn't matter, right? Going back to how we presented those formulas, we wrote log base a, our general form. Those properties will work for any log base, doesn't matter what you use. The big important feature is that when you use those properties, you're using them with logarithms that have the same base. So since all three of these are ln's, we could use those properties on these expressions without much difficulty. But here it is, here's the answer I got. If we got different answers, please email me. We can go and discuss, take a look at your work. I could be wrong, right? Don't assume that you're wrong and that I'm right. It could easily be the other way. It's happened several times already. So, but here it is. So with that out of the way, let's go ahead and try working on another example using these log properties. Okay, so for our next example, we're going to go ahead and do the exact opposite of what we just did. That meaning, what I mean by that is we're going to expand the logarithmic expression into a sum, difference, and or multiple of logs, right? So before we had a whole big expression, we condensed it down into a single log. Here we're going to go the opposite way. We're going to start with a single log. We're going to expand it out into a bunch of separate logs, all right? So again, just reusing those properties we've listed out in this video, just doing them in a different direction is all. Or using them in a different direction is all. Alright, so to start things off, again, we want to split this log up. What's the first thing I would do? Well, I would see I have a division inside of my logarithm, so let's go ahead and do the quotient property. This would then become ln of x times y to the 5th minus ln cube root of z plus 3, right? Just using that quotient property. Alright. So from here, I have a multiplication inside my logarithm. Let's use product property. So I get ln of x plus ln of y to the 5th minus ln of the cube root of z plus 3. Okay, so from here, important thing to note is we're not actually done with the problem just yet. From here, let's go ahead and use the power property to bring out these two coefficients to the front. So, doing that, we then get ln of x plus 5 ln of y minus 1/3 ln of z plus 3. And there you go, you get that. So, pretty straightforward, not that complicated. Again, just using these properties of logarithms. Here was quotient property. Here was product. And here was power. Okay? We took a single log, we used these three properties, and then we expanded it out into a expression using several logarithms. Again, just like with the other example, you don't have to do it in the way I could have done it. You could have done the product property first, all right? Then you could have moved into quotients. The one thing I will mention is you cannot use power property on the start here. You do need to break this up before you can use power property, okay? But there it is. Here's another example. Again, just using these properties. This one kind of illustrating what I was talking about before. Why do we really care about these properties? Well, if I was trying to use this logarithm expression in like a real world application, this is quite clumsy to use. It's kind of complicated. On the other hand, this bottom line, which is equal to this original expression, this is much more simpler to use, much less intensive of calculations you have to do here rather than compared to here. So hopefully this again highlights some of the usefulness of these properties. So with that example out of the way, let's again just have you guys get dirty, get your hands dirty, go ahead and do same directions, just you starting with a different expression. And let's have you guys start with, oh, actually before that, if you haven't done so already, go and take a moment, pause the video, get all this copied down. Okay, so let's go ahead and have you guys try on your own. Let's have you try this following expression. Let's have you expand it out. So go ahead and do log of x squared times z to the minus 3 times square root of y plus 1. Okay, so go ahead and expand this logarithmic expression out. Take a moment, pause the video, give it a shot, and after you unpause, I'm going to go ahead and write my answer. So go ahead and pause now. Okay, so hopefully you gave the problem a shot, and if you did, let's go ahead and compare answers. So the answer I got was 2 times log of x minus 3 times log of z plus 1/2 times log of y plus 1. There you go. That was the answer I got. Again, if we do not get similar answers, double check your work. If you think you're right, go ahead and send me an email. We can discuss. I could have easily made a mistake. But with that out of the way, let's go ahead and try another example. This time doing something a bit different, but still kind of similar to what we did just here. Okay, so for all of you who managed to make it to the end of this video, here's an extra credit opportunity for you, alright? I want you to consider the question, rewrite ln of 20 in terms of ln of 2 and ln of 5 only, okay? In other words, take ln of 20 and show that this will equal some combination of ln of 2s and ln of 5s. Okay? And what I want you guys to do is, if you can solve this problem, write up your work, email me your work, alright? I want your work and your answer. Email me your work and answer by next Monday. Email me your work and answer by next Monday, and you know what, screw it. If you email me your work by next Monday, I'll go ahead and just, whatever your lowest homework score is, I'll make it full credit. Why not? Alright? We're near the end of the semester. Let's start getting those hopes up. Trying to keep our spirits up, even with all this crazy stuff going on in the world. So go ahead and work on this problem. Send me your work, send me your answer, do it by next Monday, and your lowest homework score, we'll go ahead and make that a perfect. Besides that, that's it for today's video. Hope you guys are continuing to stay safe, continuing to stay healthy, making the best of the scenario, or your situation, whatever that may be, and I'll see you guys in the next video. Goodbye.